The method of partial fractions is meant for dealing with an integrand that has the form of a rational function. So say p of x over q of x, where p and q are polynomials. If the degree of p is smaller than q, then what we want to do is try and express it as a sum of simpler fraction. However, if the degree of the numerator is greater than or equal to the degree of the denominator, we'll use polynomial division and see what happens. If you use polynomial division, you can split up the integral as follows. So if you did x cubed divided by x squared plus 4 and rewrote it using the remainder theorem, you'd get two separate integrals. First one's basic, second one use substitution. I have an example for that you can check out. The method of partial fractions. Step 1, you want to factor the denominator as far as possible and try to make it a product of linear factors, if possible, of the form ax plus b. If it has any repeated factors, then you must represent those, and I have an example that shows this, how you handle this. You may have an irreducible quadratic factor, which means that the factor is quadratic and it cannot be factored any further. In that case, you do need to represent the numerator with a linear piece. Those may also be repeated, and if they are, you must represent them. Here's some of the examples that you can see in some of my videos.